So the first method is if I have f of x equals 3x squared minus 30x plus 4, and I'm trying to complete the square. So the first thing I'm going to do is I'm going to kick out this a value in the front. So I factor that out. So we get x squared minus 10x. So I'm just taking it out of the first two terms. The 3 doesn't come out evenly out of that 4. So what we're going to do is we're going to leave a little space, and then we're going to write the 4 on the outside. So if I were to multiply this out, 3 times x squared is equal to 3x squared, and 3 times negative 10 is still equal to negative 30x. And then I just have this 4 out there. It's not being multiplied by the 4 because we closed the parentheses. It's not being multiplied by the 3 that's outside there. So then the question is, what would complete this square? And so I'm looking for a number that I'm going to take this negative 10, which is the b value. So I'm going to take the b value, I'm going to divide it by 2, and I'm going to square it. So in this particular case, I'm going to go ahead and switch colors. I have negative 10 divided by 2, and I square that. So that becomes negative 5, and negative 5 squared happens to be 25. So I'm going to put in this positive 25 inside here. That's the number that completes that square. But then if I just put in a 25, I haven't kept things balanced. So really this positive 25, in order to balance it, I need to subtract something. So in order to get that, I'm going to multiply this 3 that's on the outside times this 25. So in order to balance it, I need to subtract out this 3 times 25, which happens to be the negative 75. So we put in a positive 75 because 3 times 25 is 75, and we're balancing out by subtracting that same value. From there, I'm going to write what we have. So when I factor this out, I get that this ends up being x minus 5 quantities squared, because this is x minus 5 times another x minus 5. And then on the outside, I have 4 plus negative 75, which is a negative 71, combining those like terms together. And there I have completed the square. And the purpose of this is to get it into this special form that shows us what the vertex is and what the a value is. So that's the first method. Here's the second method for completing the square. This one connects to those of you who like to use the box method for factoring. It's a way to use the box in order to figure out how to complete the square. So we're starting with this 3x squared minus 30x plus 4. And the first thing I'm going to do is I'm going to kick out the a and the c. In order to kick out the a value, I'm going to divide it out or take it out as a GCF. So I have 3 times x squared, and then 3 times what equals negative 30x is negative 10x. Leave some space because we're not sure what's going to happen in there. And then we have plus 4. Again, we have the same thing we started with. 3 times x is x squared equals 3x squared. 3 times negative 10 is equal to negative 30x. And this plus 4 is not being multiplied by 3. So we are still back to the original. So the next thing we're going to do is we're going to put these into a box. And again, this is for those of you who really liked factoring with the area model or the box. So what I have here is I have this x squared, and this is a special case because we're trying to complete the square. I'm going to take this negative 10 and I'm going to cut it in half. So half of negative 10 is negative 5x, and another negative 5x. Again, in terms of factoring, typically we don't necessarily cut this in half. We try to look for the magical number that multiplies to this last number and adds to this one. But in this case, we're trying to create this number here. So what we're going to do is we're going to pretend like we're kind of factoring away. So I get the x out here, the x out here. So x times x is x squared. I'm going to have the -5 out here and the -5 out here because that's what I'm factoring out. X times -5 is -5x. And then the number that actually completes the square, so where this name came from, is what would make this square of x minus 5 times another x minus 5, which is a square. What is the number that would complete it? And in this case, the thing that completes that square is a 25, and it's -5 times -5 is equal to a positive 25. So that is the number that completes the square. So in order to do that, I'm going to put plus 25 because that's the number that completes the square. In order to keep things balanced, I'm going to just at the same time subtract 25. So really, I've added nothing to the original. So I have the 3 times x squared is equal to 3x squared, and 3 times -10x is equal to -30x. And then this right here, 25 minus 25, is really adding 0, and then plus 4. So I'm still back to the original that I started with. Then from there, what I have is I don't really want that -25, so I'm going to kick it out. In order to get it out of the parentheses there, I need to multiply it by this 3 on the outside to get it to be out here. So 3 times -25 happens to be a -75. So I'm just kicking that number out to the side. So let's see what we have left. So we have 3 times x squared minus 10x plus 25. And then on the outside, we have this -71. And again, this -25, it got kicked out to the outside combined with that to get this -71. Then x squared minus 10x plus 25, the factors are really x minus 5 times another x minus 5. That's what this work was showing because we had x squared minus 10x plus 25. That's what's inside here. So when we write that in factored form, we get an x minus 5 quantity squared, and then we have this -71 that's on the outside. So that's what f of x equals. And this is considered completed the square. Again, the purpose of it is to be able to see the vertex and the a value in this particular form, in vertex form. Here's the third method of how to complete the square. So we're going to start with that same problem, which is 3x squared minus 30x plus 4. And this time we're going to do something a little bit different. I don't really want this 4 to be here. So what I'm going to do is I'm going to actually move it to the other side of the equation. So I'm going to subtract 4 just to get it out of the way while we're working with this problem. So I have f of x minus 4 is equivalent to 3x squared minus 30x. So now that that's out of the way, I look here and I'm looking for, I want to take this a value and factor it out. So I have 3 times x squared minus 10x. On the other side, I still have this f of x minus 4. So I'm looking for what number would complete this square. So I'm looking for something to put inside of here. Again, I'm looking for this b value divided by 2 quantity squared. So that b value is -10. So I'm doing -10 divided by 2. And I'm going to square that. So that's -10 divided by 2, that's -5. -5 squared is a positive 25, making sure that you're using those parentheses appropriately. So I'm going to, the number that completes that square is a plus 25. Now we're not allowed to just put in a 25. I need to keep things balanced on the other side of the equal sign. But this 25 that looks like just a plain old 25 is really a 75 that I put in here because of this 3 times this 25. Because of that, on the other side of the equal sign, to keep things balanced, if I'm going to add in a 75 over here, I need to add in a 75 on the other side. And again, that 75 is really 3 times 25. So what we have at this point, I'm going to write down what we have on each of the side of the equal sign. So this is going to be plus 71 is equal to 3 times, and then when I factor this, the x squared minus 10x plus 25 is an x minus 5 quantity squared. And the only thing I have left to do is this 71. I don't really want it on this side of the equal sign, so I'm going to move it back over. In order to move it back over, I'm going to subtract it from both sides. And what we get is f of x is just left over here. On the other side, we have 3 times the quantity x minus 5 quantity squared minus 71. And that is, we've completed the square. The purpose of this is to get it into vertex form so we can see the vertex, and we can also see the a value or the stretch factor in this problem.